Today we start matrix. Now first we have to know what is matrix and what is it used for. Actually we use the concept of matrix in everyday life, like in uh, suppose in train timetable. So here are the number of the trains, and here their arrival and departure times. So this is in a tabular form. Again, suppose your periodic table in chemistry, that is also in a tabular form. There are some rows and some columns there. Again, suppose your class routine, that is also there are some rows and columns representing the days and the number of periods. So all of these tables actually in mathematics they are called a matrix. Actually in our scientific data, actually when we represent them in some rows and columns, there are some many kind of advantages in them. Actually when we represent those data in some rows and columns, it saves our space, and also we very much it is very much easy for us to know their properties or some other things about the data. So these are actually matrix. These tables are called matrix. Now here we will see in mathematics what is matrix and why how it will be used for other purposes, other branches in sciences. Now we will see how matrix is written in mathematics. So there are some, suppose there are some data, m cross n data are there, and we have to represent them in matrix format. So how could you do that? Suppose there are we represent them in m number of rows and n number of columns. So suppose we are writing some A, B, C, D, E, F. So we have written A to E, these alphabets, in 3 rows and 3 columns. Suppose this is the first row, this is the second row, and this is the third row. And in this way we see that this is the first column, this is the second column, and this is the third column. So in this way this is a matrix representation which has 3 rows and 3 columns. In our mathematics we will write it as then. Now this is called a matrix. Suppose a matrix which has 3 rows, 1 1 2 3, and 3 columns, 1 2 3. So number of rows is 3 and number of columns is also 3. Suppose we add another column, then the number of rows is 3 but the columns becomes 4. So number of rows is 3 and number of columns is 4. So the order of this matrix, we call this the order of the matrix, is 3 cross 4. That is 3 of the first digit represent the number of rows, the second digit represent the number of columns. So 3 is the number of rows and 4 is the number of columns, 4 columns. So in generalized way we could write it as m cross n columns. Suppose A11, A12, A13 up to A1n. So 1 2 3, the indices shows that there are n number of elements there. Now 2 1 2 2 8 2 3 up to 8 to n. Here also n number of elements, a31 a32 a33 up to a3n. Here also n number of columns in this row. In every row there are n number of columns. In this way we write a m1 a m2 a m3 up to a mn, and enclosed in this symbol of matrix. Then this matrix, let us try to understand what we have written there. Suppose n number of terms are there. Look at these indices 1 1 1 2 1 3 1 n. So what does that represent? The first element remains same for the first row, but the second digit changes. The first digit doesn't change. 1 1 1 1, this represent the first row, but the second digit changes. 1 2 3 and n. So this represents these n columns. So this is the first column 1. Here also the second digit is 1. Here also the third and the second digit is 1. Here also the second digit is 1. So this, the second digit represents the column number and the first digit represents the row number, because along this row, first row, we see that the first digit doesn't change. In the second row we see that the first digit doesn't change. 2 2 2 2, that means this is the second row. 3 3 3 3, that means this is the third row. And this is m m m m, this is the mth row. And the first column, for the first column the second digit doesn't change. 1 1 1 1, so this is the first column. 2 2 2 2, so this is the second column. 3 3 3 3, so this is the third column. And this is n n n n, so this is nth column. So the first digit represents the row number and the second digit represents the column number. So if we write the order of this matrix, then we will write it as m cross n. The m is the number of rows, so there are m number of rows, and the second digit is the number of columns. N number of columns is there. So in short we may write it as here the elements aij element has, this means the A matrix is comprised of these elements aij, which uh, which has m rows and n columns. Aij are the elements of A. So these elements are arranged in m rows and n columns, and their suffix ij means this varies, ij varies in m and n. I is from 1 to m and j is and j is from 1 to n. So I varies from 1 to m and j, the second digit, the column number, varies from 1 to n. So this is written in short the whole matrix. If we elaborate this, then this becomes the whole matrix which I have written before. Now we will learn about different types of matrix. So what are the different types of matrix? The different types of matrix are, first we see that rectangular matrix. What is rectangular matrix? Rectangular matrix means it will be in the shape of a rectangle. Suppose A B C D E F. So this matrix, see, this matrix has 3 columns and 2 rows. That means 2 rows and 3 columns. That means the rows and the columns are not same. Either or another, we consider another matrix A, B, C, D, E, F. Here, here also the elements are A to F, here also the elements are A to F, but these are represented in this form and this represented in this form. Here the number of rows is 3 and the number of columns are 2. Hence we see that this is 3 cross 2 and a 2 cross 3, that means 2 rows and 3 columns. Here 3 rows and 2 columns. In both cases the similarity is the dissimilarity is this the number of rows and number of columns are not same. Here the number of rows are 2, number of columns is 3. Here number of rows is 3 and number of columns is 2. So these actually are in the shape of a rectangle, so we call them as rectangular matrices. Now we learn about square matrix. Square matrix. What is square matrix? Square matrix, it is very obvious from the name that square matrix means the rows and columns will be same. Suppose we 1 2 2 1. Here the number of rows is 2 and number of columns is also 2. So number of rows and columns are same. So it will be in a shape of square. So this is called a square matrix. That means the number of rows equal to the number of columns. The number of rows equal to the number of columns. Then the matrix is called the square matrix. Actually, in the scope of our syllabus, we will deal with this square matrix. Almost every matrix problems we will see in the square matrix form. So this will be of greater importance for our syllabus. Now another type of matrix is called row matrix. What is row matrix? Row matrix means row matrix is a matrix where there is only one row. Only one row is there, is called a square matrix. Then it will be 1 cross 4, only one row and 4 columns. 1 2 3 4 4 columns are there but only one row. So this is called a row matrix. So in row matrix the number of rows is always equal to 1. Similarly, we have another thing, that is the column matrix. What is column matrix? Column matrix means it will be of a single column. Suppose 1 2 3. So there are 3 rows there but only one column. So this is called a column matrix because there are 3 rows but only a single column. So in column matrix the column number is 1, in row matrix always the row number is 1. In row matrix the column number will be whatever you want, and in column matrix the row number is whatever you want. But in column matrix column will be always be equal to 1, and in row matrix the row will be always be equal to 1. Now we move to next. This is called null matrix. It is also of great importance in our matrix operations because we know the importance of 0 in our algebraic operations, because if there is no 0 then the subtraction is almost impossible for us. Now null matrix is also of similar usefulness. Suppose null matrix is represented as a big O or 0. Bold 0 is written in the book, a bold O or bold 0. You could write it as big O. So null matrix is the matrix which has all the elements as 0. Now what would be the here in this matrix it is 3 cross 3 matrix, but null matrix is identified as a matrix which has all the elements at 0, but it has no specific order. It may be equal to this, may be equal to like this, or maybe like this. This is rectangular, this is row, this is column, this is square matrix. Whatever be the matrix, whatever type it may be, but the similar thing is that all of the elements are equal to 0. So this is called a null matrix. Now we see the diagonal elements of a matrix. What is called the diagonal elements? Diagonal elements are the elements if we require a square matrix first. This is a square matrix, suppose. So this is a 3 cross 3 square matrix, 3 rows and 3 columns. Diagonal elements are the diagonal. Actually, if we have a square, then this is the diagonal. So here also the diagonal is this. Elements are called the diagonals. If we write it in a general form, then first element is called a11, second element is 112, 13, this is a21, this is a22, and this is a23, this is a31, this is a32, and this is a33. So in generalized way, these are the elements. This is a 3 cross 3 matrix. Then this see the diagonal elements. Here the diagonal elements are a11, a22, and a33. In other words, if any element of this matrix is aij, then the diagonal elements will be aii or ajj. That means I and j would be equal for the diagonal matrix. This is a11, this is a22, this is a33. So first and second digits are same, a11, a22. So these are the diagonal elements. Always a11, a22, a33. Whenever an element I and j indices are same, if it is a square matrix, then if I and j are same, this must represent the diagonal elements of the matrix. Okay. Now trace of a matrix. What is trace of a matrix? What is trace of a matrix? Trace of a matrix means the sum of the diagonal elements. Sum of the diagonal elements. Here 1 plus 1 plus 3. This is the trace of this matrix. The sum of the diagonal elements is the trace of that matrix. Now we have learned about diagonal elements. Now we will learn about diagonal matrix. Diagonal elements are these elements along the diagonal of the matrix, but diagonal matrix is the matrix which has non-zero elements only in the diagonal elements and other elements are 0. The diagonal elements are the non-zero elements and other elements, the non-diagonal elements, are all 0. Then this matrix is called diagonal matrix. So when do we call a matrix diagonal matrix? Whenever the diagonal elements are only the non-zero elements and the other elements, the elements above the diagonal and the elements below the diagonal are all zero. They are all zero. Then this is called the diagonal matrix. Now scalar matrix. Now what is scalar matrix? Scalar matrix is a kind of diagonal matrix. Here in the scalar matrix, it is a diagonal. Actually scalar matrix is a diagonal matrix. Actually this is a diagonal matrix, but a special type of diagonal matrix. What is that? What is that special type? The special type is that all the diagonal elements will be equal. All the diagonal elements will be equal. In diagonal matrix we see that the non-zero elements are the diagonal elements, other elements are zero. If those diagonal elements become equal, all those diagonal elements become equal, then that diagonal matrix is called a scalar matrix. Then this is called a scalar matrix when all the diagonal elements are equal. And of course the other elements, non-diagonal elements, are zero, of course, because this is a diagonal matrix. Actually this is a diagonal matrix, but whenever the diagonal elements become all equal, then this is called a scalar matrix.